Lesson 6, Calculating Normal Distribution. So, if you have a set of data, you're just given the data, you have to calculate certain things before you can see if the data is distributed normally. So, I'm going to give you the mean, the deviation, and the median. If you had a question like this, you would have to calculate them. And if you don't remember how to calculate them, you have to go watch the lessons from lessons 1 to 4. So, first, your average, your mean, is 2.526. And you find that by adding up all the numbers, then dividing by n, the number of terms. And the standard deviation is 0.482. And you have a formula to calculate that. And the median is 2.55. So what we're going to do is we're going to create a frequency table, and our intervals are going to be the intervals you would have for a normally distributed curve. So we know that our median is 2.526. We want to add a standard deviation above it, which is 0.482, and that will equal 3.008. We want to do this twice to get all of our intervals. So 3.008 plus 0.482, 3.49, and 3.49 plus 0.482 is 3.972. So those are our three intervals on the right of the curve. Now we have to do to the left. So 2.526 subtract 0.482 is 2.044. 2.526, 2.044 subtract 0.482 is equal to 1.562, and 1.562 subtract 0.482 is 1.08. So these are going to be our intervals. So we're going to make a chart. This. So this is going to be the interval, the tally, that doesn't look like a T, there we go, and the frequency. I don't have a lot of room. Oops. Oh well. Okay, so from 0 to here, 1.08 is our first interval. From 1.08 to 1.562 is our next. 1.562 to 2.044, 2.044 to 2.526, 2.526 to 3.008, 3.008 to 3.49, and 3.49 to 3.972. So there's all of our intervals. So now all we're going to go through is the data and make a tally in our frequency chart. So the first one is 2. So 2 will go in this one. So what I want you to do is I want you to go through all of the information, cross it out, put it in the right column. 1.7 goes in here. 2.6 goes here. 3.2 goes here. So I want you to pause the video, and I want you to do this on your own, and then I will put the correct answer in, and I want to see if you check to see if you did it correct. Pause video. So here's your correct answers. You should have 0, 1, 7, 17, 18, 6, and 1. And if you just look at the information, it seems to make a curve with your tallies, and it makes a curve with your numbers here. So 1 and 1, 7 and 6, pretty close. 18 and 17, they're basically the same thing. So you can tell that this is normally distributed. The second part of the question, example 2, says use the data above to sketch the normal curve. So we're going to use that data to sketch the curve. So our curve looks like this. It's normally distributed. We know that our mean is 2.562. We have 1, 2, 3 on each side. So we're going to put in all of our intervals. So 3.008, 3.49, and 3.972. And on the other side, 2.044, 1.562, and 1.08. And last is to put in the percentages, 34, 34, 13.5, 13.5, 2.35, and 1.15. So there is our curve. Example 3 says, if you're purchasing the cell phone above, what is the likelihood that it will last at least 18 months? So our data is in years. So you're going to get 18 divided by 12 is 1.5 years. So 1.5 is right here. So that means that to the left of 1.5, those phones didn't make it 1.5 years. But everything to the right did. So what I want you to do is I want you to sketch out the curve for part 3. So just sketch it out. And we have all of our sections. Really rough sketch. Doesn't have to be really good. And we know that 1.5 is right here. And we want to shade everything else that we're looking for. So we're looking to everything right of that line. It is really hard to shade on the iPad, just so you know. Okay. There we go. So that means we need to add up the percents that are shaded. So we have 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. That's all of the green shaded sections. And all together, if you add them up, you should get 97.5%. So the likelihood of you getting a cell phone that lasts longer than a year and a half is 97.5%. And we've all had cell phones, so that seems high because my cell phones don't last 1.5 years. But that's how you do it. So add up all the percents that it covers, and that's your answer.